This episode is brought to you by CuriosityStream. You won't see it coming. But what follows has enough power to reshape the world. Since 1945, the world hasn't fought with nuclear weapons, which means you probably don't know. Really understand their devastating power and be thankful. But understanding the reality of what they can do, the destructive potential locked within the tininess of atoms, is why this can never happen. The nuclear age began on July 16, 1945 in the New Mexico desert. 3 weeks after, a bomb was detonated over Hiroshima, Japan, and a second on Nagasaki 3 days later. Nearly 200,000 people were killed instantly. Unprecedented destruction. Over 70 years later, nuclear war remains an unimaginable concept for most of us, but it hasn't become impossible. That took about 1,000th of a second, 1 billion times longer than the processes that detonate a nuclear weapon. These explosions reach the interior temperature of the sun, over 100 million degrees Celsius, hot enough to vaporize anything near the hypocenter. And that's only a blast's first effect. Nuclear weapons work primarily in two ways that at their core both exploit the forces binding an atom's nucleus. Fission bombs, like the weapons that struck Japan, split atoms apart. When a nucleus rips in two, it can eject neutrons. This emits a burst of electromagnetic energy, and scientists discovered this does bad things to radioactive isotopes like uranium-235. When U-235 atoms are packed together, each split atom sends neutrons hurtling towards their neighbors, which absorb them and split again. If each neutron ejected causes more than one atom to split, a chain reaction builds and builds until the mass of the fission products and the neutrons released is less than the original U-235, and that extra matter is converted into pure energy. Hell hath no fury like E equals MC squared. The earliest nukes only fissioned 1 or 2% of their fuel. Even that was enough to produce an explosive yield equal to 15 kilotons of TNT. But it didn't take long for us to upgrade their effects by adding another nuclear process, fusion. Hydrogen bombs, or thermonuclear bombs, came later. They're more powerful because they're really two bombs, a fission and a fusion bomb. In the first stage, a fission chain reaction triggers an even more powerful atomic process, fusion. This initial energy compresses and superheats fusion fuel. Unlike the heavy atoms used in fission, light hydrogen isotopes are violently smashed together to form heavier clusters. But same as fission, the change in mass from start to finish releases a catastrophic amount of energy. After all, it's what powers our sun. Fission or fusion, all this atomic pinball happens faster than you can think. After these first few nanoseconds, the larger effects of a nuclear explosion begin to radiate out in waves. Assuming you weren't reduced to your most basic elements at detonation, next you'd experience the thermal wave. Anything within several kilometers is instantly incinerated in the 6,000-degree heat blast, which even farther out can cause full-body third-degree burns like being engulfed in flames. A fraction of a bomb's energy is released as gamma and X-rays, which slam into air molecules, ejecting a light-speed electromagnetic pulse that can disable anything with circuits. But only some of the energy from a nuclear explosion is released as light and heat. Most of the damage comes from the blast itself, from debris or the shock wave that radiates outward, compressing the atmosphere into a wall of pressure moving hundreds of miles per hour, enough to level an entire city like a house of cards. Hot air from the explosion rises fast, and the resulting vacuum sucks more air toward the heat and more oxygen to fuel the fireball, sending the column up and up. The cloud above Nagasaki stretched high enough to interact with the ozone layer. And at this height, it stops rising and spreads out horizontally, forming the cap of the iconic mushroom cloud. As that cloud dissipates, radioactive particles begin to fall, blanketing nearby areas with radioactive dust that can kill survivors and rescuers in just days due to acute radiation poisoning. Winds and rain can carry fallout far beyond the weapon's initial target. In the 1980s, Carl Sagan and other scientists began exploring a concept called nuclear winter. The idea is multiple explosions, like in a nuclear war, would raise huge clouds of dust and radioactive material high into Earth's atmosphere, blocking out the sun for weeks or months. This would lower Earth's temperature, slow the growth of plants, disrupt the food chain, maybe even trigger another mass extinction on this pale blue dot. Depending on the size of weapons and where they're used, as few as 100 explosions could cause major climate change. And even a handful of small-scale weapons would likely have measurable effects on our weather for years. The first moments after a nuclear detonation would unleash the terrifying power of physics on anyone and anything nearby. But in the wake of nuclear war, the outlook for our entire species is just as dim. The issues surrounding nuclear weapons are incredibly complex, but science has not only let us create one of the most violent tools imaginable, it's also let us understand what will happen if we use it. Or if we don't. Stay curious. Hey guys, this episode was brought to you by CuriosityStream. They've been supporting It's Okay to Be Smart for a long time, and it's an awesome place to learn even more about the stuff that we talk about. CuriosityStream is a subscription streaming service with documentaries and other nonfiction titles from some of the world's best filmmakers, including a bunch of exclusive originals. You should check out Miniverse. It's hosted by my favorite space Canadian astronaut, Chris Hadfield. He takes a road trip across America to put our solar system in scale and learn about it along the way. You can get unlimited access today, and for our audience, the first 2 months are free if you sign up at curiositystream.com/smart and use the promo code SMART during the sign-up process. Thanks for watching, hit that subscribe button, and I'll see you next time when we learn something new together.